everybody, hello from your favorite artist electronist, Mr. Q12, with a fantastic achievement that I copied from internet. But I'm telling you, it was a real struggle to actually find the proper code. I tried so many things, but now I find the right thing, the right code for the right component that I'm having. And in all my searches and all my tryings, well, I didn't do too many tryings. I didn't tested too many codes, but I did look everywhere on YouTube, on internet, on written texts, on datasheets. I searched like a crazy man. I searched, and finally, I started to put head to head to see my mistakes, pretty much to visualize where I'm doing wrong and where I should improve my thinking to get what I want. So I put my project aside on this other table, and I build a new testing circuit through Arduino, directly commanding these two components, Rotary encoder and RGB LED. I made some test codes for both, and I will discuss the RGB LED in the next movie probably. For now, I spent a couple of days, 3 or 4 days, I stayed on this Rotary encoder to figure it out. So this Rotary encoder is quite a serious problem because from what I understood so far, it's a misconception that they are the same. They are not the same. There are different factories that are making a slight different rotary encoder type from one to another. So let me give you an example. So here on AliExpress, if we are searching for rotary encoder, we get this very commercial type of encoder, these ones that I have. These ones here presented on this page are the same, except this one. This is different. But this one, what the fuck? This one, probably this one as well. This one, this. So the large majority that are pretty much, they are looking the same. They are the same here on this page. But what I'm referring is with other websites that are selling their products, or some factory products they are linked to. I'm not completely sure what is going on internet these days, but it appears like that. So I did this mistake by believing they are all functioning the same, and I discovered it's not true. Let me see here. So you see this is looking very similar. It's just as the name says here, rotary encoder, you see, but it's having an illuminated RGB inside it, and that's why you see that a transparent knob, and it's tiny. And this is from SparkFun, I believe is an American website. I find this guy very lucky for me. He gave this link here, and this link sent me to his page, his website, with his Arduino code here. Let me actually open it, and this is his test code. That it didn't work. I mean, it did work in my side, but it worked with fantastic errors, very nasty errors. So for this one, I have to actually change from these pins here to there, where is using some specific interruption pins. So I have to take this to A and B wires and move them on the other side. Let's see, there, and Control P. So it's pin 2, is 0, 1, and 2. That's how it's working. And this guy here. So 0, 1, 2, 3. 2 and 3 are the for A and B pins, are the interrupt pins. Okay, so this is the code from that guy. I have to actually upload it. So this code actually didn't work for me, but I will show you nevertheless. I have to open serial monitor, this, and when I'm rotating from here, this is a very important detail. You have to pay attention to the baud rate of testing codes. So this guy is using 115, and I have to choose mine to be 115 as well. You see, when I'm rotating from here, is starting to appear these numbers. But check this out. When I'm in the middle here, when I'm moving it between the holes, what garbage is throwing. My other tests, it did skip some numbers. Yeah, you see here, 17, 16, 17, 18, 19, something like this. There are a lot of errors in his code for this particular knob or rotary encoder that I'm using, and is not the same as his. That's the point. Although the circuit, what I'm using there, is the same. The resistors are going to the positive and the common negative and everything. It's this bastard. It's that little bastard. This is a simple, very quick test just to show you how unresponsive or wild his code was. Let me clear everything and let me rotate only once. So right now he's sitting inside a hole. When I'm moving it to the next hole, look what it's doing. It's counting to 4. You see, it's counting 4 times. And now if I'm rotating even more, and it reached. So you see the error is repeating. So it got to here, and now is catching a 5, 4, 5, 6, 7, 8. So it's very erroneous. This code is not working for me. I like the code actually. It's very smart code, but it's not working. So that's it for this part. Uh, but in his video, what he is presenting there, yeah, you see his numbers are perfect aligned. There are no skippings. It is 9, 0, 1, 2, 3, 4, 5. Well, probably is running back 3, 2, 1, 0, 9, 8, 7, 6, 5. So his encoder is behaving. The code is doing the job perfectly. Is this exactly this test code? But in my version, it gave me a ton of errors. I was actually panicked a little bit because my code didn't work. This guy code didn't work, and I was like, what the fuck is going on? I got this link here, encoder used in video. So this is his encoder component, and when I clicked on it and I got there, it tell me that this is not anymore here. That link is not working anymore on this website. But then I used my fantastic hacker brain, and I understood it's on this domain, on this SparkFun domain website, and I simply search for Rotary encoder, and from very small list actually. Let me back it. So this is the entire list on this website. It's not having that many Rotary encoders. You know, when you search for it, when you search for Rotary encoders, you don't get too many options. And I just, I watched his video and I said, well, maybe this is the one that he used, but without the board. So this was the closest to his. And then I actually, I find this data about it, and then the data sheet here. Let's open it a tiny little bit, and it's full of Chinesium, but also it is providing a circuit diagram here, and also here is a circuit diagram for the bouncing. So this circuit, it also helped me to build the circuit that you are seeing here. So I built after I've seen this circuit here, I kind of duplicated, but not completely, not correctly as there. I introduced these two capacitors, which are 10 nanofarads, not 100 nanofarads like I'm usually doing. And I'm having this resistor that you can barely see it, but it's there. This is a resistor there, and this one from that pin. In the middle is the zero rail. That these two capacitors are one leg on that zero rail, and here, these two resistors are coming from A and B pins. Here together, both of them. At this point, that you cannot see it very good, but they are, you see, they are there in the same hole, linked to this red line, which is going into the positive on the Arduino there. And that's it. And these two lines are on A0 and A1. Yeah. You see? A0 and A1 pins. And that's it. And I'm having a wire for negative and another wire for 5 volts that I'm collecting from Arduino board. That's it. And this is a RGB layer that I will talk about later. I'm having two components in test right now. This on this board is what you are seeing. This rotary encoder and this RGB, which I will talk about it later. And this is the schematic what I'm having here. Although here, if you are paying attention, it is having an extra 10 kilo here in line with the output, the green wire that is going into Arduino board pretty much. But it doesn't matter if this point is here or here, with or without this resistor is really not that significant. It's like having a 20 kilo here on the top is the same. So I didn't bother to add it. But this little detail here, it helped me to try less capacitance than my usual 100 nanofarads. I use 10 nanofarads. So this page from SparkFun here is a link to gray code from Wikipedia. And I looked here and I catch my ears on top of my head. And look at this disaster here, how this is counting. Unbelievable. And this is a simplified version here. And yeah, no way, Jose. So it's a bit more complicated than what I bargain with. At least is going in, in too much depth. I know about gray codes, but yeah, it's too much. It's over my ears, this part. And then I actually find some very interesting code here on this page. Yeah, this one, converting to and from gray code, from binary to gray, and from gray to binary. And I was actually trying to, I stayed and I understood what is going on there. This is exclusive word, this sign here is actually mentioned here in this comment. And this number is shifted to 1. And exclusive word, if you are looking here on this table, is 0, 1 is 1, 1, 0 is 1, but 1 is 1, 1, or 0, 0 is both 0. So when something is different is 1, and when either pins are the same, on 0 or on 1, they are 0. This is what this little code is doing here. This is what is returning, and I believe it will return exactly like a boolean, but in this unsigned int form. So it will output a 0 or 1, I believe, when it will return back. So this is what this function is doing, from binary into gray. And from gray to binary is a bit more complicated. It's reversing what this is doing here. Kind of the same logic. It's also XOR it, and also shifting and comparing them, and then returning something. And it will output a 1 or a 0. And this is a very interesting one. Is XOR with an equal, and this is a special way of doing things. And then is shifting. This is a bit more complicated, but it's very interesting to see this very different ways of programming that I never used, but I kind of understand them when I'm looking at them. I have to actually put my hands on them and actually use them to learn them and to get experienced with them. Okay, that's it about the gray code, and it's very interesting subject, but it's way out there. So I thought maybe there is a simpler way of finding a result. So like I said, I was desperate at some point. So then it popped in my mind to actually search my specific, exactly this guy, or this guy, I have the blue ones, these guys. So exactly this, these guys, actually, let me check them. And let me open them here. So exactly this guy's datasheet. So that was the idea, to find their datasheet. And this is what I did. Exactly this is what I did. Rotary Encoder datasheet. Very stupid naming, very generalistic. And I clicked the first link here, and I got on this page, which is showing this board. But the module, the Rotary Encoder, is the same with this AliExpress one. Only this plastic color is different, but otherwise is the same product, is the same idea. And when I was looking, I have the habit to scroll to the end of every datasheet. I'm not reading, I'm just looking at the pictures, at the pretty pictures. I swear to God, and catching fragments of the text. There, I kind of start to recognize what is what. And here in this datasheet, I was scrolling down, and then I see a code. What is this code? And when I'm looking a bit more closely, it's saying here Arduino Uno. Hopa, this is for Arduino Uno. It's not for a microcontroller or something else. And then the serial monitor. And I said, oh, excellent. This is for Arduino code. And I said, well, let me actually make a new test Arduino code and copy this code and put it there in my code. This is a Rotary test code that I used from that guy, from the guy with in the movie, that it didn't work. And this is his circuit that he used. And you can see here the same diagram like in the datasheet. I forget to show it. And I saved some screenshots, and his Rotary encoder is having actually 8 pins because it's having that LED inside. That's why. So, and also a button press, exactly like mine. So it's a bit more complicated. So this is that project that it didn't work. So his code was using interrupt pins that I don't use them on my final cardboard or board. And then I created this folder here, Rotary Test DOI, and this is the datasheet that is opened. And thank you, Mr. Hudson from Hudson Technology. You did a great job making this PDF here, and it literally you save my ass. So this is the test. You can see here the name 0 Rotary Test DOI is that there. It's already programmed in my Arduino. I don't have to program it again. I only have to call this this serial monitor, clear everything. And when I'm rotating from here, watch what is happening. Well, it is going down. Let me clear it. And now, look how beautiful! How beautiful! I was so happy when I seen this code working. I was, oh, wow. You have no idea. So this is clockwise, and now I will turn it back to 0 in counterclockwise. So this is back. As you can observe, if you are following the numbers, it's doing 2 by 2. It's 2120 and then 1918. Yeah, you see 19, 18, 16, 14, 12, 10. So like I said, let me make you a short. So when my cursor is here in this hole, it's passing through this bump and it's creating a 1. And then another one here, and then it's going into this hole. And when it's finished, so when it's making contact here in this point, when it's making contact exactly there in that little margin, it's creating a 1. Sometimes it's creating here between these two in my my code that I made it, a 1 or a 0. So I could move it back and forth, but not actually going into the holes. And when it's exiting, when it's not in contact with this second, is creating, I don't know, another one or a 0 or whatever. And when it's getting into this hole, it's not touching anything. The next, let me switch back. So this is the next here, like this. Like this. Like this. The next one. So it's exactly in between. It's not touching anything. And when you are moving the knob, you are repeating the thing again. This is what I'm feeling when I'm moving this knob. It's only the feeling. So right now it's stationary in a hole, and when I'm turning it, is jumping into the next hole. So, but when I'm between, yeah, you see, it's actually incrementing and decrementing correctly. Actually, fantastic, and is only in that gap in the middle of the track, like I showed you. I have to make it again. So this is the segment, and this is the hole, and this is the. So what I did right now, I played between these two segments, but not getting out of them inside the hole. So I was keeping the knob, playing it on this track, that is, I'm feeling it like a bump, is actually like this, a little bit curved, is a little bit curved like that, you know, like that, to show you in a 3D view. And here is like a hole like that, and my cursor is going into the hole and then is rising up on this track, and of course is getting on this gap between those, and then on the next gap, which is on the other side. I hope you understand what is going on here. So this was a very, very big problem with my code, with that guy code, and finally I find this guy on just internet, and I just copied and paste. I only changed what I changed, pin 3 and pin 4, which are not used for interruption. Pin 2 and 3 are used for interrupt, but he is using pin 3, which is an interrupt, but then is using pin 4, so he is not using the interrupt per se. He is using it as a normal button press, pretty much, and a very, very clever code. I didn't even look to decipher his code. When I test, I only test his code, and when I've seen it's working, holy fucking shit, this is glorious. This is what I wanted from the very beginning. And I wanted to share with you that this is fantastic. This is truly fantastic. And I wanted to share the idea that not every code on the internet is good, and that is working with what you are having, and that there are differences there are different models of Rotary encoder. This is a very valuable information that I wasn't aware of, and I had to bump my head on different walls and different errors until I realized this little and subversive detail. It's a very obscure detail that nobody will tell you, but I will. I am telling you. So give big thanks to Mr. Q12, who is teaching you the real deal. All right, this is it for this part with this Rotary encoder, and then, and as you can see, it is working absolutely fantastically well. And doesn't matter the speed. I actually tested it for very fast, and it is performing excellent. It's not jumping anything. Is just perfect, just fucking perfect. And I'm very, very, very happy. Right now, I am very happy. But I was very lucky to actually find this code. Fucking shit. I forget to record, and I was showing here. Unbelievable. Motherfucker of pizdy mati. Yeah, so this is what is doing here. Let me actually run it very slow. Let me go to 0, clear everything. So now it's recording. Unbelievable. So 3, 4. Yeah, you see? This is doing 2 times here. As you can see. So, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, you see how the knob is turning, and how it's incrementing there. And it's very extremely responsive. Extremely responsive. Yeah. Fucking hell, I don't know why I forget. Sorry about that. Alright, that's it. That's it for this part. Bye bye.